projects. In this video, we are going to explain about a project titled A Novel Noise Adapted Two-Layer Ensemble Model for Credit Scoring Based on Backflow Learning. Coming to the introduction part, one of the distinctive features of this model is its ability to adapt noisy data. In real-world scenarios, datasets may be plagued with noise and inconsistencies, which can severely affect the performance of traditional credit scoring models. However, the noise-adapted approach implemented in this novel model allows it to discern relevant patterns amidst the noise, leading to more accurate credit risk assessment. At its core, the noise-adapted two-layer ensemble model leverages a multi-layered architecture that combines the strength of various individual classifiers. These classifiers work collaboratively, harnessing their diverse perspectives to make informed and robust credit risk predictions. By integrating multiple models, the ensemble model mitigates the impact of individual weaknesses and ensures a more comprehensive and reliable credit scoring process. So our main objective for this project is to provide financial institutions with a more robust and accurate credit scoring system, ultimately benefiting both lenders and borrowers by promoting a fair and reliable credit assessment process. Handling noisy data. One of the key objectives of the model is to effectively deal with noisy data commonly encountered in credit scoring. By implementing noise-adapted techniques, the model can discern relevant patterns and reduce the impact of data inconsistencies, leading to more reliable credit risk predictions. Enhancing predictive accuracy. The model's two-layer ensemble architecture leverages the collective strength of various individual classifiers. By combining their perspectives, the ensemble model can enhance predictive accuracy and capture complex credit relationships that might be missed by traditional single model approaches. Incorporating backflow learning. The utilization of backflow learning is a pivotal objective of this model. This process enables the model to integrate feedback from higher level classifiers, allowing it to iteratively refine its lower level predictions. This continual improvement mechanism results in a credit scoring system that evolves over time and adapts to changing credit landscapes. Now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. So in hardware requirements, first we have operating system, that is Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first we have upload credit dataset and apply IFNA processing. To building the novel noise adapted two-layer ensemble model for credit scoring, the first step involves uploading the credit dataset. This dataset contains information about various credit applications, including their financial history, personal details, and credit outcomes. However, datasets are often prone to missing values, which can hinder model performance. To handle this issue, the IFNA, that is flag not available processing technique, is applied. IFNA replaces missing values with a specific marker or assigns default values, ensuring that the data set is complete and ready for further analysis. Second, run extreme gradient boosting, that is XGBoost. Here, XGBoost is a powerful and widely used machine learning algorithm known for its exceptional performance in regression and classification tasks. In the context of credit scoring, XGBoost is employed to create a first-level classifier. It utilizes an ensemble of weak decision trees to make predictions and iteratively correct errors to refine its performance. By running the XGBoost algorithm on the credit dataset, the model generates initial credit risk predictions. Third, run gradient boosting decision tree, that is GBDT. Here GBDT, that is gradient boosting decision tree, is another popular ensemble learning method that builds a strong predictive model by sequentially adding decision tree. As part of the noise adaptive two-layer ensemble model, GBDT is applied as a second level classifier. It learns from the mistakes made by the first level XGBoost model, improving the accuracy of credit risk predictions and refining the ensemble model's overall performance. Fourth, run SVM. Here SVM stands for Support Vector Machine, which is a widely used supervised learning algorithm known for its effectiveness in binary classification tasks. As a component of the ensemble model, SVM is employed to build another classifier. It works by finding the optimal hyperplane that best separates credit-worthy and non-credit-worthy applicants. Fifth, run random forest. Run random forest. Here, random forest is a versatile ensemble learning method that creates multiple decision trees and combines their outputs to make predictions. In the context of noise-adapted ensemble model, random forest is run as another classifier. It introduces more diversity into the ensemble, reducing the risk of overfitting and improving the model's generalization capabilities. Sixth, run linear discriminant analysis, that is LDA. Here, LDA is a dimensionality reduction and classification technique that aims to find the best linear combination of features to separate classes. Within the ensemble model, LDA is employed as an additional classifier to contribute its unique perspective on credit risk assessment. It helps in capturing relevant patterns and relationships in data, further enhancing the ensemble's predictive performance. Seventh, run backflow learning. Backflow learning is a key component and one of the defining characteristics of the novel noise-adapted two-layer ensemble model. It involves a feedback mechanism where the higher level classifiers such as GBDT, SVM, and random forest provide feedback to the lower level classifier, that is XGBoost. 8. Accuracy graph. The accuracy graph visually represents the performance of the novel noise adapted two-layer ensemble model. It shows how the model's accuracy evolves during the training process as more classifiers are added to the ensemble. The graph typically plots the accuracy against the number of iterations or the number of classifiers used in the ensemble. This graph provides insights into the model's learning process and highlights the benefits of the ensemble approach, demonstrating how the accuracy improves with each added classifier, including the backflow learning component. Now coming to the execution part. To execute the project, first we need to open the code folder. Here you can see we have a folder named as dataset. In this we have two files that are training files, which is .csv, and testing files, which is .txt. And here you can see this is the main Python file which contains the Python script in it. This is the run.bat file. Instead of executing the program in command line interface, we created windows to bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here, this is the graphical user interface. With this, we are interacting with our program. Now, click on Upload Credit Dataset and apply IFNA processing button and upload dataset. Click on Open. And here we have applied SMART algorithm to remove outliers and to solve class imbalance problem. Here on this screen we can see dataset contains 690 records, an application using 552, that is 80% dataset records for training model and 138 for testing. Before applying SMART, we can see there is class imbalance as class 1 contains 305 records and class 0 contains 247 records. After applying SMART, we got equal number of classes. Now click on Run Extreme Gradient Boosting button to build boosting model and to calculate accuracy on test data. Here we can see extreme gradient boosting got 85% accuracy and we can see precision and recall values of. Now click on Run Gradient Boosting Decision Tree button to calculate its accuracy. Here we can see 56% accuracy. Now click on Run SPM to get its accuracy. Here we can see SPM got 67% accuracy. Now click on Run Random Forest button to get its accuracy. Here we got 73% accuracy. Now click on Run Linear Discriminant Analysis button to get its accuracy. Here we got 85.50% accuracy. And now click on Run Backflow Learning button to get backflow accuracy. Here we got 82.60% accuracy, which is more than all others BAS classifiers. Now click on Accuracy Graph button to get the graph. Let me expand this graph. Here you can see x-axis represents algorithm names, whereas y-axis represents accuracy values. For all algorithms, backflow ensemble algorithms got better accuracy. So here in this console, we can see predicted values for each classifier, and here for each test record, we can see the predicted class over here. Now coming back to the conclusion part. In summary, the novel noise adapted two-layer ensemble model represents a significant leap forward in credit risk assessment. Its ability to handle noise, incorporate backflow learning, and leverage ensemble techniques make it a game changer in the field of credit scoring, promising to drive greater financial inclusion, fairer lending practices, and improved risk management for years to come. Through its ability to handle complex credit scenarios and capture non-linear interactions among variables, the novel model surpasses traditional approaches in its predictive capabilities. This translates into fairer and more informed credit decisions, benefiting both lenders and borrowers in the financial ecosystem. The novel noise adapted two-layer ensemble model for credit scoring is poised to revolutionize the credit industry, offering a powerful tool for financial institutions to assess its creditworthiness accurately and efficiently. As more institutions adopt this cutting-edge approach, borrowers can expect a more transparent and equitable credit assessment process, while lenders can optimize risk management strategies.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.